Question number 23. For a wire, Hooke's law is obeyed for a tension F and extension X. Okay. And Young's modulus for the material of the wire is E, which expression represents the elastic potential energy stored in the wire. Now, what happens is when you say Hooke's law is obeyed, that means when F is increased, X also increases, right? Usually what we do is when we say elastic potential energy or work done, we directly take F into X. When can we take this one? When we should not take this one? We can take this one only when the force and the displacement are constant. That means it does not vary with time, it does not vary with any other parameter. But unfortunately, here it is not so. When force also varies, displacement also varies because it's an elastic band. So therefore, what you need to do? You need to always go by a graphical method to determine the work done. So towards it, now if you plot a graph of force versus displacement, you will get a straight line. Why straight line? Because we know from Hooke's law, F is equal to minus kx or F proportional to x over here. So it should be the straight line. Now what is the work done? Work done is obtained by using the area under the curve. When you say area under the curve, what is the area under the curve? Area under the curve is nothing but half into base into height. Height is what? F over here, which should be equal to F into x divided by 2, which is the right answer here. F into x by 2 is C. Okay, so it is not D.